Hi, I'm Peter Adamson, and you're listening to the History of Philosophy podcast, brought to you with the support of the Philosophy Department at King's College London and the LMU in Munich, online at historyofphilosophy.net. Today's episode will be an interview about Galileo and the telescope with Eileen Reeves, who is professor of comparative literature at Princeton University. Hello, Eileen.
Hello.
Great to have you on the podcast. I'm very excited to talk to you about this, especially because you're an expert on, among other things, Galileo's telescope. And I thought an obvious thing to start with would be the question of how Galileo's telescope worked. How was it constructed? What did it look like? How powerful was it?
Thank you. That's a great question to begin with. I'm drawing a lot on the work of Albert van Helden, who gave us the first rudiments of understanding why it was that the telescope emerged when it did. Because you had its basic components a long time before the telescope was invented, allegedly in the fall of 1608 in the Netherlands. So, what took them so long? There was a great engraving about 1600 that almost makes this point. It's a series of engravings about new inventions, and there's one devoted to eyeglasses in particular. And so you see various people reading with eyeglasses and doing leather work and this and that and the other in an eyeglass shop. And in the middle of the engraving, a young man who's myopic, wearing very thick lenses, and his eyes are small and beady. And you see right next to him an older man holding out a lens maybe 6 inches from his face. And that's clearly for someone who needs glasses for reading. So the obvious question is, why weren't these things put together? So, what Albert van Helden worked out is that you were going to have a concave lens, like the one that a myopic would use for the eyepiece or ocular, in combination with a convex lens for the objective glass, the thing that looks at the object, and a tube that connects them. And you need the tube to shut out light, but also you need it to keep those two lenses aligned. You need the focal points for both of the lenses to coincide somewhere near the retina. And if you work it out, you would probably have a weak convex lens with about an 18-inch focal length in combination with a pretty strong concave lens with a focal length of about 6 inches. The way you get magnification is that you just divide the focal length of the objective glass by that of the eyepiece of the ocular. So if you had something like 18 inches over 6 inches, then you would have a magnification of 3. It would magnify things 3 times, which is about what they probably had in the Netherlands. The constraints here are, first of all, the available lenses. There were much, much greater range of lenses for people who needed glasses for reading. And until maybe the 19th century, these were assigned by age. So eyeglasses for a 60-year-old, 70-year-old, etc. The ones for myopes were harder to get, made to order, and just harder to grind. In a normal eyeglass shop, you wouldn't necessarily have a great number of those. And the constraints are the available lenses and the quality of the glass. And also, an important constraint is, if we believe the narrative that this invention came about because someone was idly switching these lenses and seeing how you could get something that was both enlarged and sharp, it can't be much longer than the length of their own arm. It was probably that initial spy glass was probably pretty short, probably only about 12 inches in length. And in the case of Galileo, we don't have extant his very earliest telescope, but what we do have a lot of textual documentation about it. It was called occhiale a tromba, meaning trumpet-shaped glass, and that's because his earliest telescopes, which we no longer have physically, were flared at the end. They were trumpet-shaped, and this confused people elsewhere because they had just a straight pipe. But the idea was that you would use a very large convex lens at the end, the object glass, not because that changes optical power, but because you're polishing only the very central part. So, to give an illustration, if I asked you to polish something that's the size of a contact lens, it'll be a lot easier if I say, oh no, take this larger lens and polish just the central portion, the size of a contact lens. So that's why the thing was flared. And then lastly, early users of the telescope realized that it would be somewhat better for certain objects to be able to push in and push out the eyepiece. And so what they did, and sometimes the texts are explicit about this, they used something that is like akin to the tuning bit in early trumpets, something that would raise and lower the pitch so you could push in and pull out the eyepiece as needed to bring the thing into focus. So those are the three components, four if you count the tuning bit, the mobile part, the tube, the push in, pull out part, and the two lenses, concave near the eye, convex in the object glass.
And there were at least legends about people being able to see things from far away all the way back to antiquity, right?
Oh yeah. Yeah, there's a lot of 'em, and at some point, the legends and the things that actually work sort of overlap. But among the things that actually work and that were influential, especially in the Latin West, Aristotle is distinguishing between the ability to see things that are remote and the ability to bring them into focus. So something like the problem that between myopia and presbyopia. And he says in passing, you can see stars during the daytime from wells. And this passage, which he made, I assume, just casually, was taken up in the early modern period. And Galileo mocks someone in his dialogue saying, oh, yeah, there was a professor who lectured saying that the telescope had been invented by Aristotle in antiquity, that the well served as a tube, and the vapors in the well had a lens like effect. And Aristotle was just too modest to trumpet this invention of his. But that worked a little bit. You can see stars if you're in the bottom of a well. There are also sighting tubes. So there were a lot of manuscripts in which tubes being held by Ptolemy, for example, or Aristotle or Boethius or whomever, to look at the heavens. And it's just an empty tube, but it was often mistaken as a telescope. There's also Seneca and others would recognize that if you have a glass that's clear enough and you fill it with water, it'll have a slight magnification effect. So it's helpful for reading. And then those are an ancestor of Leisensteinen or reading stones, which I think were often made of something like rock crystal. So that helped for reading. There was also concave mirrors since antiquity, but especially in the early modern period, they got a little bit better. They were microscopic aids. Then, of course, there were eyeglasses of varying quality to correct vision. And then, most importantly, and as a kind of antecedent to the telescope or to the Dutch telescope, and then later to the Keplerian telescope, there were mirror and lens combinations. And these were somewhat built on fables, legends, and somewhat true. The fables would say that many different empires in Rome or in at the lighthouse of Alexandria or in the Far East, the ruler had a concave mirror usually set up high in a tower from which all enemies approaching the empire could be seen. So in general, it's a motif for an overextended empire. So there was this tower to survey the land and incoming enemies, and the mirror in the story is always either rusted if it's metal or busted if it's glass by the time the story is told. It's a retrospective story. There are instances in which towers were set up with a mirror inside of a dark room and sometimes with a convex lens in the aperture. So that did actually work. It didn't work very well, but it was a kind of a dark room device for seeing what was going on around one. There are other lens and mirror combinations in which you could have the image come into a concave mirror and the mirror could be tilted and one could look at it through a weak convex or concave lens. So that was a lens and mirror combination. And finally, there were periscopes to send images via mirrors from one place to another around a corner. And there are manuscripts that rehearse that. And I remember seeing a manuscript note that said, this won't work very well. So there is some overlap between the fable and the actual physical thing that worked.
By the way, just to dwell on one little detail in that amazing story you just told us, if you look through a tube, even that doesn't have a lens at something, it turns out it does actually help you see the distant object, right? So you can see a star a little bit more sharply if you look through a tube because it eliminates interference or something. I don't know why it
Yes,
works,
it
but
does.
it does work.
It takes out this circumambient light. And I even saw in a discussion of this was in an English language text that people, everyone would be making of their fist a perspective, they said. In other words, a sort of tube. And you can still do it today if you need to see something a bit closer. As you say, the
Yeah.
tube works.
Yeah, listeners can try this at home using like the tube left over after wrapping paper or something. Okay, and maybe before we get to Galileo, just one other thing. What happens in the Netherlands at this time? Is there's a big breakthrough, or is it more like they use trial and error to grope their way towards more powerful
Well,
instruments?
we don't know because, in part, because the information that survives is largely, not exclusively textual. There is some pictorial evidence, but it's subject to an author's ideology. So Al van Helden shows that there are three main protagonists who suddenly turn up with the telescope all in the fall of 1608. And two of them are searching out patents. And one of them looks like a charlatan type based on his criminal record that he heard about a good thing and maybe wanted to imitate it. And these were glass lens telescopes of about magnification of 3 powers. And quickly, this telescope or a version of it shows up at the Frankfurt Fair soon after, in the weeks right after that. René Descartes tends to exaggerate the differences, the distance between the trial and error of the artisan and his theoretical approach. And this is in his dioptrics in the introduction. And he regards it as a great shame that the telescope came about by, as he sees it, by trial and error, random experimentation. So one of the so-called inventors of the Dutch telescope is named Jacob Metius, and he's a lens maker. And his brother, Adrian, is a university professor and an early Copernican and an early observer of sunspots. And Descartes tries to push apart that kind of knowledge or say that in general the one was not inflected by the other, that there was very little overlap. But in the case of brothers, it's somewhat hard to believe. And he also even describes the lens maker himself, the Dutch lens maker Jacob Metius, as someone who experimented with mirrors and lenses, but he says using ice. In other words, suggesting a kind of something temporary and almost impoverished about it. And the stories after Descartes that talk about the Dutch invention will sometimes say it was a lens maker's children that were playing around with lenses, or sometimes even a simpleton that was playing with lenses. And in part, this piggybacks on the fact that we tend to think of glasses as synonymous with intellectual activity, but in a lot of early modern representations, rather foolish people are wearing glasses. They make you look goofy. So the idea that experimentation could have been taking place by someone who's radically uninformed and even stupid is of a piece with other popular representations of eyeglasses.
Okay, maybe it should be noted that we're both wearing eyeglasses as we have
Yes,
this discussion.
absolutely.
Let's move on to Galileo, who nobody would think was a simpleton. Before we get into his actual use of the telescope, maybe we can connect this to what he'd been doing beforehand. So he's done this work on falling bodies, he's interested in mathematics. Was optics part of that? Was he interested in optics as a science? How does his interest in the telescope fit into the rest of his mathematical enterprise? Or is it just when he hears about the telescope because he's interested in astronomy, he thinks, oh, I could point that at the sky? Is it that's just that simple?
Galileo is somewhat covert or discreet about his early work on optics, but we can reconstruct some. Like his friend Paolo Sarpi, he did some prior work on optics, but especially with lens and mirror combinations. And the fact that those could be combined misled them a little bit when they heard the rumor of the Dutch telescope. Galileo also had a lot of training in perspective and worked closely with artists. So that helped him both rendering images, but also in understanding what it is that the eye is seeing. We also know that a decade or more before the invention of the telescope, he took very careful notes on a schematic representation of how mirrors work, where their focal point is, what a concave mirror does, how they not just propagate images, but also sound. He was very attentive to this manuscript and copied it fully. We also have some little exchanges between him and a visitor that suggests that he worked with a parabolic mirror. And then, in one of the earliest references to Galileo in print in 1601, a kind of frenemy, some sort of rival, describes him as Prometheus. It's a very short little poem and not a very good one about Galileo. But Prometheus is known for setting fire with the mirror. So it seems gratuitous otherwise. Why call him that? And he calls him a new Euclid, etc. He doesn't point to his work in astronomy, but definitely points to some sort of activity that maps onto optical expertise. But one of the most interesting things is that Galileo developed over the course of some decades a compass, or what we might call a sector, for patrons. And it did two things. It helps you calculate. So, for instance, if you wanted to make a projectile of a certain weight, it would tell you, okay, if the projectile is composed of this metal, then the volume should be thus. If it's composed of this other metal, the volume will be different. In other words, that compass or sector had inscribed on it what we would call specific gravities of different metals and stones and of certain woods on it. And he varied these scales for different patrons. But the other aspect of this sector was a surveying tool so that you could look at distant objects and estimate their height from afar by using a series of congruent triangles and looking at the shadow that they cast, etc. And there are scales on this sector that allow you to do that, to calculate the angles and the distance. And Galileo is very discreet. Again, with this work, he only circulates it in manuscript and he teaches people how to use this sector or compass, and he gives them manuscript directions for its use. And he didn't want it to go into print because it would be too easy to copy and then he would no longer have a monopoly on it. Inevitably, of course, someone does take one of his manuscript manuals for it and put it into print and in a bad translation. And Galileo takes him to court. But one of the things that this rival did, or this plagiarist did, was fault Galileo's sector for its lack of optical qualities. So he is clearly believing that you should be able to train your eye along the edge of the sector, probably through a small sighting slit, or what is called in Italian a traguardo, a thing you look through a loop, and saying, why can't I see something with it? And Galileo, in the court case, is mocking him a lot for holding it at the wrong angle or expecting to see things that were not there. But the reason that mistake was made was that many of these surveying devices use lens and mirror combinations or set up a lens in it. And so there was a notion that Galileo's lens and mirror work would eventually result in something of optical value, something worthwhile. I think he's fairly discreet about these rather modest returns. I don't think it was shop ready, but there are enough hints to suggest that he and his friend Paolo Sarpi are very interested, at least in the optical properties of mirrors, and probably in combination with the lens, well before the Dutch telescope emerges.
I guess the first question would be that's what happens, right? So he hears about it, he hears a description about it, he hears rumors, as you said. It's not like he's copying a physical telescope, right? He has to build one himself. Does he know how it works? This is going back to what you were saying about Descartes, about like trial and error versus actually having a theory about how it would work and building it accordingly.
As far as I can tell, there's a long and frustrating distance between when the telescope emerges in the Netherlands, and the news of it traveled very, very quickly, and when Galileo comes up with it. So the Dutch telescope emerges in September 1608, and Galileo has a working telescope of his own in the summer of 1609. So not a year, but close to. He probably heard the rumor, certainly Paolo Sarpi did, by November 1608. And one question would always be, why didn't Sarpi convey this? Sarpi's letters make it clear that he assumed that this was a lens and mirror combination. And by chance, at the very same moment that the rumor of the Dutch telescope emerged, there was competing rumor that the Jesuit confessor of Henri IV, of the French king Henry IV, had a vast mirror in which he could see distant objects. And Sarpi assumes that these are objects of related rumors, that this thing that emerged in the Netherlands must have involved a mirror. So they tried to contact the protege of the Jesuit confessor to Henri IV to ask for details. And in part because this protege is a friend of theirs and worked with them on this sector or compass that I just described. And it takes a while for them to get in contact with him. And eventually, in something that we don't have, he must have said, no, it doesn't involve a mirror. It's a different type of instrument. Because by then, in France, you could already buy a cheap and not very good telescope on the Pont Neuf in Paris. So eventually, they get the information that it involved two lenses. We know that Sarpi saw or encountered a Dutch telescope and probably wasn't allowed to examine it, but might have recognized its components. Galileo made some crucial innovations pretty early on. He stopped down or put a paper diaphragm on the object glass. In other words, so that you're looking through just that very central portion. And he might have done something to the inside of the tube to darken it. And he probably had better glass to begin with than the Dutch lens makers. So he changes the shape of the aperture. You could make it oval, or you could make it round, or you could move the diaphragm entirely. He also shortens and lengthens the tube. And if you want to do any sustained observations, you'll need a bracket. So he makes a Y shaped or U shaped bracket. And he does tell in early letters, before he has this bracket, he's still working with the tube. So the lenses are aligned, but he talks about how much your own breathing and your own pulse will shake the telescope. So it's very important to have a kind of stable stand for it, and not they just borrowed from standard diopters, standard implements. There was this Y or U shaped stand on which to rest the telescope so you don't affect it by your own body. I think he's fairly reserved about details, both because he wants to cut down on competitors, also because even when he gets his telescope to let's say, 9 power magnification in the summer of 1609, and then eventually up to 20 and even 30 magnification by the winter of 1610. The telescope can't explain everything. In other words, he has ideas that the telescope will not verify. And the last thing is that we discovered pretty recently that he had a shopping list, and he had sent someone from Padua to Venice to pick up lens polishing materials and also an organ pipe. So, one of the early components that he used was an organ pipe, and he knew two organ masters in Venice because of his musical connection. So, that might have made this even easier. He uses an organ pipe, probably something of pretty soft metal, to align the lenses, and probably regarded it as a throwaway thing, but a prototype for one of those early telescopes.
Okay, so that's funny because I sometimes give an example of sort of a limit case of what might be interesting to the historian of philosophy. And I say, could you be interested in a shopping list, for example? And it turns out the answer is yes, you could be interested in a shopping list. Speaking of philosophy, so now we've looked at the kind of technical innovation here in some detail. So let me ask you a few philosophical questions about this in conclusion. One is, I guess, a question of epistemology. So if you're looking through something that is magnifying the object 10, even 20, 30 times, it's obviously giving you a very different impression than you would see with the naked eye. So are there worries about whether it's falsifying what you're seeing, whether this is a reliable instrument?
There were a lot of worries, and sometimes I think they're motivated just by jealousy, but they're also legitimate in that the telescope didn't work especially well, or certainly didn't work the same for all who used them. The telescopes, first of all, varied a great deal in quality, and Galileo's was almost certainly better than anyone else's around. That said, it was, as we would call it, a pretty primitive instrument. But there are many incidents in which people are seeing radically different things with the same telescope. And there are people also who would not look through them because they figured that the telescope was not exactly mind altering, but maybe eye altering. Something like when I was little, parents would say that if you cross your eyes, they will stay that way. So there were people who felt that their eyes would be permanently damaged by looking through it. But there's also the case that Galileo goes to another rival's house with the telescope fairly soon after he publishes The Starry Messenger in 1610. And he wants to show them the satellites of Jupiter. And according to the one report, no one can see them, but no one else can make them out. And allegedly, and this was a very hostile account written by a very young and ill mannered person, he says that Galileo was so upset that he left early in the morning and didn't even say goodbye to his host. The guy who wrote this unflattering account also said, though, that in the middle of the night, he crept into the room where the telescope was and made wax casts of the lenses. So he must have believed in it to some extent. But if you look at less biased accounts, when Galileo encounters the rings of Saturn, he sees the rings as two small globes on the sides of Saturn. So when he writes about that in a letter, he writes a small o, a capital O, and a small o by way of notation. The Jesuits at the same time are working to improve their telescopes, and Galileo needs them to verify some of his findings. He doesn't think that they will rush out in front of him and discover stuff that he has not yet encountered, but he would like some ratification. So he shares this with them. And the Jesuits see the rings of Saturn as olive shaped. So obviously, there was a great variation in what one saw with similar telescopes. When the sunspots are an object of scrutiny, Galileo's Jesuit rival, Christoph Scheiner, spends a very long time trying to prove that the sunspots are not some defect in the lens, because lenses did have impurities. And at the same time, people often put, especially if they were doing direct observation of the sunspots, they put colored lenses on top of the object glass, a blue lens or green lens, something like sunglasses today. That distorted the sunspots a bit, particularly in size. If you couldn't bring the object to focus, the circumambient rays would make the object seem a good deal larger than it was. And because there was an erroneous belief that stars, for instance, were scattered throughout the universe in various places in a non-uniform fashion, but that they were all the same size. It mattered if you got the size wrong because you think that the size is an indication of the star's distance. There was a very poor resolution for things like the phases of Venus. When Galileo was trying to establish the phases of Venus, it takes him quite a long time, given the optics of his telescope, to see that crescent shape that he's looking for. To some extent, the camera obscura, where you take your telescope but you train it into a dark room, was meant to be a corrective to all of this. We have the same telescope, we're all looking at the same thing at the same time, and we project it onto a white screen. But now, if you go into a camera obscura with young people, for instance, as I have done, they will see all kinds of things that you don't see. They'll see an amazing range of details that are just not visible to you. And also, there is still, with telescopes and without, a great range in the way people perceive colors. So there was every reason to believe not that the telescopes were wholly illusory, but that much of what they conveyed to early observers was distorted. And it took quite a while for it to be regarded as a reliable tool.
That raises so many interesting issues that I think will occupy us going forward. So these problems about replicability, like if your instrument is better than everyone else's, that's great, except that no one else can replicate your results. And the way that these instruments actually create these very artificial kinds of experience. And that makes me wonder what Galileo thought he was doing. So do you think that when he looked through a telescope, he thought that he was just seeing, but seeing in a better way than anyone had seen before? Or do you think that it was more like he would have a hypothesis about what he might see, and then he would train his telescope at something and try to confirm the hypothesis? So I guess I'm wondering, is it more like an extension of Aristotelian empirical science, or is it more like an anticipation of the scientific method, as we could call it nowadays? Sorry, that's a big question.
It's a hard question, but a worthy one. If we think about Venus, for instance, so the phases of Venus were meant to be a very robust form of confirmation of the Copernican world system. Long before the telescope, even centuries before, there was discussion of why wouldn't we see Venus pass in front of the sun? And one answer is we don't see it because it's just not there. It doesn't pass in front of the sun. But others would be no, the orbital plane of Venus doesn't align in our plane, the ecliptic. Another one would be, and this is less exciting but more obvious, is that it's just too small, or that the sun is just too bright, or that our eyes are just plain not good enough. So Galileo anticipates well before he can actually observe the phases of Venus that it should have this lunar like pattern. Galileo waits for the phases of Venus to be visible to him. And when he finally does observe them, he sends out an anagram. Years later, when he's writing his dialogue on the two chief world systems, he has copious praise for Copernicus for inferring that Venus must have phases, even though he never encounters physical evidence for it. When we see stories like that, we would say, okay, Galileo is much more interested in theoretical model, and he's willing to wait for evidence to show up to verify that he's not going to let the absence or ambiguity of empirical results dissuade him from a notion of a Copernican world system. He also has, for the same reason, he's interested in the use of twin stars to verify the Copernican world system. And so, in theory, if there were stars that are close together, viewed against a starry backdrop, you would be able to notice a slight shift in their position if you are on a planet that travels around the sun over the course of half a year, let's say, you should be able to see that. And this was a theoretical argument that Galileo and others made. Galileo must have looked for this from probably about 1604. He probably became interested in this around the new star of 1604 because he mentions a lot of circumpolar stars that are double stars. And he's waiting for such evidence. And occasionally, a colleague of his, Castelli, whom he trusted, will write to him and say, there's a good opportunity to observe these stars. He waits for this until he's writing the dialogue concerning the two chief world systems. So in 1632, even as he's preparing that manuscript, he's still waiting for evidence that he won't see. And he has to admit that neither our instruments nor our eyes are good enough to see this. And he anticipates that one day one will see it. In general, in the early days with the telescope, he's hesitant to say, my telescope is not good enough to see this. But later on, as he builds up more and more evidence and telescopes improve, he's more willing to suggest a kind of futurity in the instrumentation. At the same time, I would say that, okay, he seems driven by theoretical expectations, but there were so many exciting discoveries that neither he nor anyone else anticipated. The sunspots, for one, which were not known in the Latin West, the rings of Saturn, or the companions, as he called them for another, these are new phenomena for which there isn't an apparent rubric. So, of course, he swoops in opportunistically to discuss them. So, I would say that there was a kind of back and forth between a theoretical model where you're looking always for empirical data, but you're not going to give up that model, or you will adjust it only slightly, and scouring the heavens for this and that and the other unimaginable thing and rushing into print with the news of it. Yes, I think it's a back and forth.
So, one last question, and this is now looking forward to what's going to happen in the 17th century. As you just mentioned, actually, Galileo takes us into the 1630s. So, we're already well into the 17th century by the time his final trial comes along. There's a lot we could talk about here in terms of Galileo being a kind of harbinger of what's to come. But given that we've been focusing on the telescope, so to speak, maybe we could just think about this change where instrumentation is starting to play a huge role in science. So we have not only the telescope, we have the microscope, and then we have other instruments going forward. And that seems to me to be a real kind of watershed moment in the history of science and also the history of philosophy. Would you agree with that?
Yes, I think so. One part of Galileo's genius was the wish to put together both observational data and some form of quantification, and, where possible, graphic representation. You're not just presenting an image of the heavens, but let's say in the case of the sunspots, you can infer from the sunspots their approximate size, the distance, which was fairly small, that they must have from the solar body, the time it takes them to traverse the solar hemisphere. You can infer all of that. In other words, you can quantify sort of messy, random, shape changing objects. There are other things For instance, the business about using the double stars to infer the Earth's motion around the sun and the shift in the double stars, where he realizes those angles are so small that there's no way that you would be able to represent them in realistic fashion. There's no line fine enough. These distances are so remote. So there is a huge gap between what you might draw, which would be a caricature, and what is actually happening. No diagram could capture this except in caricature fashion. So I would say that his legacy is both about the instrument and its uses, but also its limits. What cannot be seen, what we'll have to wait for because our senses will never be good enough and our instruments are not yet good enough. And also, what cannot be easily captured by even the finest engraving, even the most skillfully made diagram. So, some kind of border that would shift slightly between these realms. And occasionally they all overlap. Occasionally you can see something and you can quantify it and you can render it in pictorial terms, and all are realistic. But often those are separate domains.
Okay, thank you for that tour de force of illustration and discussion of Galileo. That was really fantastic. This marks a very exciting moment in the podcast, actually, because with that, we've now finished talking about philosophy in the Renaissance, philosophy in the Reformation, and we are now officially going to be doing what listeners have been asking me about for years and years, like when will I get to the 17th century? And the answer is next episode. So we've done Galileo now, that already took us into the 17th century, but it's only a few episodes away until we meet, for example, René Descartes, who came up in this conversation. And in general, we're going to be launching into many episodes on early modern philosophy. That's going to be the 17th and 18th centuries. And we're going to be looking at that for years to come. At least I hope we are. That's exciting. That's what's waiting for us. But for now, I will thank Eileen Reeves so much for coming on the podcast.
Thank you for having me.
And I will invite listeners to join me for the kickoff episode, introducing everyone to early modern philosophy here on the History of Philosophy without any gaps.